Welcome to episode 5 of our tutorials about drone show and swarm missions using PX4 and MAVSDK. Up until now, we used the PX4, MAVSDK and offboard control to build the basic drone show application. Now we can create some astonishing shapes, trajectories and animation in the sky using these scripts. In this video, we're gonna improve our swarm project to something beyond just a simple drone show. We're gonna create the basics implementation of a real swarm mission, which is based on leader-follower mission. In this project, we're gonna define several drones. We're gonna have one or more leaders and several followers. We could also have some intermediate leaders, so the followers would always follow their associated leaders. So sit tight and let's see what it's about. But before that, let's review what we have covered so far. In the first video, we created some trajectories auto-generated, such as heart shape or H shape, spiral, zigzags, and then we used the offboard control and MAVSDK to command our drone to create those trajectories for us in the sky. And then the viewer from the ground would see this animation and with some light effects would see some beautiful animations in the sky. Next, we improved our drone show to just create some shapes in the sky. We used skybrush animations, and we create some animations. We could use a shape of a bird, shape of an airplane, or a letter or text in the sky using skybrush. Then we created the output file. We used the output file of the skybrush and converted that to the protocol that we use in our application. Next, we created a ground station and coordinator app that takes care of all the management for us. The ground station is still a command line application, but soon it will convert it to a GUI, so it will have graphical interface. But now it's just a command line application using Python. And the coordinator app is an application that is going to be run on the companion computer on the drone. It's going to take care of all the data handling, communication and data handling, managing or triggering the drone show, and send the data to the different nodes and manage the operation for us. In this video, we're going to expand what we have done so far. We're going to create drone-to-drone and drone-to-ground control station telemetry system. So in the last tutorial, we only have the drone-to-ground control station telemetry. Now we're going to have drone-to-drone communication as well. We're going to implement the leader-follower swarm mission, and we're going to review the definition and concepts behind the swarm missions. In the bottom right picture, you can see and get a sense of what it means. We usually have a top leader, but doesn't necessarily means we have a top leader. Sometimes we have two leaders, just like the picture on the left. We have two separate swarms. But sometimes we have a top leaders and several group leaders and several followers. This can go as crazy as you like. You can have different communication. You can have some followers that become a leader for another layer, and these nodes can communicate with each other, so know what the other drones are doing. This is still under progress. This is in the beta version. Just wanted to share with you and get some suggestions or any help that anyone just want to offer. It's appreciated. But it's still under progress and it's improving. So this is just a basic preview of what it's gonna be later on. Let's review the system overview. This is just a little different than what we have in the last video. In the last video, if you have watched so far, you know that we had 4 drones. Each of them have a different IP, and the control station had 2 applications running inside that. One of them is the drone control system, which is a Q ground control or any other Mavlink based ground control station. Swarm control application, which is an application that we have developed. It's gonna take care of receiving the telemetry, processing the telemetry, and send back the data and commands to the drones. Let's go deeper and see what is happening inside each drone. This shape is also somehow look like the overview that we had in the last tutorial, but with some minor modification. Again, coordinator is in the middle of everything. It's gonna take care of all the scenarios and manage everything. In the real world, you don't have software in the loop. You're gonna be directly connected to the serial after your PX4. I'm gonna just skip the details that we covered in the last video. So I'm just gonna skip the details. If anywhere on this video anything didn't make sense for you, go ahead and make sure you have followed the last tutorials. This is the 5th episode of this, so make sure you have followed all the concepts and definition. So in this video, we're gonna have a software in the loop that's gonna be connected to the coordinator using UDP. We're gonna have a web server that drones can get the config and swarm definition and the synchronized time. The new part that we have here is a CDH subsystem, which is communication and data handling. This system is gonna receive the telemetry and commands from the coordinator, and it's gonna receive the telemetry from other systems and other drones. So each of the drones is gonna send its position, velocity, and status to other drones as well. So drone 1 knows where the drone 2 is. In the last tutorial, each of the drones were doing something offline. They didn't know about other drones around them. So they are just doing the paths that they are commanded to do. But in this scenario, drone 1 knows exactly where is drone 2, and drone 2 knows exactly where is drone 1, and they know what are they doing. For example, drone 2 knows that drone 1 is a leader for it, but itself is following another drone. This is gonna look like a boss here. So he knows which one is the boss, which one it should follow, and so on. The communication between the nodes is just like the communication between nodes and gun control station. It's based on UDP, and it's gonna be sent on the same port. So nothing fancy on the technical side here. On the technical side, everything is the same. The same way that the data is gonna send to the gun control station, the data is gonna be sent to the other drones as well. Beside the CDH system, everything is just the same. The only difference is that when the time comes and the mission should start, the coordinator will trigger the offboard MAVSDK, but the offboard MAVSDK is no longer the last mission. Last mission was following a predefined trajectory from the CSV, but here the offboard control is gonna do something very crazy. It's gonna receive the telemetry from the coordinator. Coordinator get the telemetry, process them, and give the offboard MAVSDK logic the data that it needs. For example, drone 2, if it's following the drone 1, this information is where is drone 1 and what is its velocity. So based on that, offboard MAVSDK would decide where to go with what velocity. Right now in this very basic demo, there's nothing going on exactly here. It's just gonna follow whatever telemetry that it receives from the leader. It's gonna follow that with an offset, the offset that we define later on in the next step. We define the NED offsets, altitude offset, and it's just gonna follow that. But in the next steps and the next tutorial, we're gonna improve this offboard MAVSDK logics to have some estimation, so it will be smart. I'm gonna use the Kalman filter, so the drone 2, the follower, after a few seconds, get a sense of what vehicle 1 is doing, so it can estimate. When the telemetry receiving is very slow, or maybe 2 or 3 seconds have passed and no telemetry has received, drone 2 can estimate what drone 1 was doing during this telemetry loss. Because we have the vector of the velocity and the vector of the position, so we can estimate what is the drone 1 is doing. And if we do that, the trajectory and the movement would be much more smoother and it wouldn't be jerky anymore. But in this video, it's just a basic implementation, and the movement are jerky and sometimes very wide. This is the concept behind what we're gonna do in this video. Now that you know the concept, let's follow along and follow the tutorial and see how it works in action. Let's see how you can run this demo for yourself. Make sure you have watched all the videos before this version 0.5, otherwise none of the steps we're covering in this video would make sense for you. So make sure you have watched the version 0.1, 0.2, 0.3 and 0.4, and by the time you're checking this GitHub repository it will be either version 0.5 or later. So you can download the version 0.5 from releases, or you can use the git clone and clone the repository. Remember, each episode has a different YouTube tutorial, so I assume you have watched all of them and you know what we are gonna do in this video. Okay, when you downloaded and clone the repository, open it in Visual Studio Code or any other platform that you desire. You remember that we had a config.csv file. We would define our ID, position ID, initial position, map link, IP and ports for our swarm control and drone show. In this version, we have a new file called swarm.csv. In this swarm file, we're gonna define our swarm coordination, offsets and definition. As you can see, we have 4 drones. Drone 1 is a master here, so it's not following any drone and no offset is defined for that. And drone 2, 3, 4 are following the drone 1, each of them with minus 1.5 meters north, 1.5 meters east, and 2 meters up. So each drone has a offset in NED coordinated system. And you might have several leaders, several followers. And the swarm file would automatically download it from the URL that you have put here when you run your coordinated app, or you can use just an offline swarm.csv, just like config.csv that we had in the last version. You could either read the swarm from online source, or you can use the offline version that you already have in the current directory. So each time the swarm definition would be updated. You can use the capability in this version using the debug and log library. You can go ahead and enable the log printing or debug printing, different level of logging and printing to the screen. So if you have any problem, you can enable the debug. In this file, you can go ahead and search logging. You can change the logging info, logging level to the debug or info or none. And you will get the debug messages that what's wrong with your implementation. And make sure you have installed the geographic lib library, navpy library. Simply go ahead and use pip install and install navpy, geographic lib and so on. So it's just a piece of a cake. Once you have done that, the next step is running our VMware nodes. Remember, we have a separate VMware or Ubuntu instance for each of our drone. For simplicity, I have 2 instances here. One of them is drone 1 and another one is drone 2. You should make sure you have installed everything in both of them. So both of them has PX4 software in the loop and MAVSDK drone show. In the root directory of our MAVSDK drone show, each of them should have a file called 1.hwid or 2.hwid and so on. This is the hardware ID of the drone. So when you install this script on your drone, each one of them should have a different hardware ID. Just simply change the name of the file. This is just an empty file. This helps the scripts to know which drones they are. And if you want to use the QGround control, you need to change the map link ID as well. Go ahead to your PX4 software in the loop build and go ahead and change your in the directory build software in the loop etc init-d-posix and open the RCS file. In this file, you need to change the map link ID of your drone, since QGround thinks all the drones have the instance of 1. So you need to manually change using prompt set map_sys_id to 1. You can change the global variable PX4 instance as well, but I couldn't get it to work. I don't know, it should be some problem with my configuration. So you can manually change the RCS to change the map link ID. Do the similar thing for the drone 2 and any odd number of drones that you have. This is the drone 2 instance. We go to home, PX4 autopilot, build, then we go to etc init.d-posix. You can also do it using terminal. Let's do this one from terminal. We open the terminal in this file. We can use Visual Studio and open the code, or we can use the Nano or any text editor that you like. Go ahead and search for param sys_id and change it for the ID of your drone. If you are uploading this code to a real drone, you can just simply change the sys_id from the parameter of the QGround controller as well. But if not, if you are using software in the loop, you have to do it here. So remember, this step is only required if you are using software in the loop and QGround controller. Otherwise, you can do it directly from QGround. Once you did that, everything is ready, and now you can go on and run our simulation. Now that our software and hardware environment is ready, let's go ahead and run our demo. On the top left, you can see the drone 1 instance, top right drone 2, bottom left the QGround control, and bottom right our ground control station terminal app. Let's go ahead and run the software in the loop PX4 on both our drones. Each one of them has a software in the loop. Let's go ahead and run the software in the loop with JMapSim. You can use any other flight simulator that you like for your drone. Next step is to cd it to our GitHub repository, which is MAVSDK Drone Show, and run our Python script python coordinator.py. Since in the last step we have defined our hardware ID and map-link ID, QGround control automatically finds and detects both of the vehicles with the correct ID of them. Our application, which is coordinator.py, will also recognize each of the drones and know their roles, know which one of them is leader, which one of them is follower, and which one of them is where. Let's take the drone 1 fly, we give it an altitude and let it fly.
Vehicle 1 take off flight mode.
Also, let's run our ground control session. You can see telemetry from drone 1 and 2 are coming, and drone 1 is climbing.
Vehicle 1 hold flight mode.
Similarly, we can go ahead and let the drone 2 also take off. Right now they are on the same position, but it doesn't matter, since when the swarm operation starts, they will automatically arrange their position, so it doesn't matter.
Vehicle 2 armed.
Drone 2 is also taking off. You can see from the graphical interface and also the telemetry on the bottom right. Now we are ready to run our swarm operation. As you can see, both of them right now are on state idle, and mission is none, since we haven't sent any mission to them. For sending a mission, we're gonna type the letter S and a number. Letter S means a smart swarm, and 10 seconds it means that both of them would be triggered 10 seconds from the command, 10 seconds later from the command. Right now the swarm operation is started, and drone 2 went to the exact position that we defined, 1.5 meters to the southeast of the drone 1, and also 2 meter altitude deviation. So drone 2 is 492 meters and drone 1 is 490 meters. And now the fun parts begin. We just simply command the vehicle 1 to go wherever we want, and drone 2 simply follow that. Here it is. And they also follow the heading of each other. So drone 2 turns to the heading of 60 degrees and goes to drone 1 position and 1.5 meters to the southeast. That's it. We can even make it more fun. We send the drone 1 to a mission, send the drone 1 to an orbit of altitude, maybe 5 meters relative, and let the drone 1 go ahead. And drone 2 will automatically go to the orbit as well with the arranged configuration that we defined. It goes 1.5 meters to the southeast of the drone 1, and now the maneuver starts. We can see that vehicle 1 is in orbit mode, but vehicle 2 is in off-board mode. Vehicle 2 has no sense what it's gonna do in the next 5 seconds. It's just following drone 1. It doesn't know that it's gonna do an orbit. It's just follow drone 1 with the coordination that we defined. Remember, this is the most basic example to get a sense of swarm definition. We could have several leaders, we could have several followers, we could have intermediate leader. For example, vehicle 2 right now is following vehicle 1, but maybe a vehicle 3 would follow vehicle 2, so vehicle 2 would look like a leader for vehicle 3, and so on. We could have recursive leader follower operation here. It can go as crazy as you like. Now that we tell the vehicle 1 to return to home, Again, vehicle 2 has no sense at what it's gonna do. It just follows drone 1. Drone 1 is returning home, climbing to 30 meters and return home, and vehicle 2 would do the same. With the same configuration, 2 meter altitude offset and 1.5 meter to the southeast. They return and now they are landing.
Vehicle
This is the
2
most
hold
basic
flight mode.
example. And remember, there's something that this project lacks right now is a little bit smartness from vehicle 2. The follower is just receiving the set points and do what it's supposed to do. It's not doing anything by itself. Right now, I'm implementing a Kalman filter. So using a Kalman filter, vehicle 2 can estimate what is going to be the next step. So by knowing the position and velocity vectors in real time, it can decide what it's going to do in the 1 and 2 seconds later on. So in that case, the trajectories and movements would be much more smoother. So this would be the next update, maybe the next update for this video. I hope you have enjoyed this video as much as I did so far. I just want to mention this again, that this project is still just a preview. It's not ready for real world operation. There is still a long journey remain. I haven't done anything about the fail-safe scenarios, the command acknowledgement, the telemetry data loss management. So there is still a lot remaining. So it's not ready for real world operation. If you're gonna use it on real world operation, it's at your own risk. So go ahead and test it with software in the loop and let me know if you succeeded to make it to work. I'm improving this project. It's still on the earlier stages, and as I told you, there's a long journey remain. If you have done a similar project or you're doing similar project, if you have any advices, recommendation, feel free to send it to me. And if you don't want to miss the next tutorials and videos on this subject about swarm drones and smart drones based on AI, make sure you have followed this YouTube channel and like and subscribe to this channel if you like. Up until the next video, have a nice flight and good day.